Hi, welcome once again to another class with Domoji Math and Science. We'll continue with our physics classes, and in this lesson, we'll be seeing Newton's laws of motion. We'll start the first and the second law, and in subsequent class, we'll see the third law of motion. Rest tells us that a body will continue in a state of rest or uniform motion in a straight line unless an external force acts on it, compelling it to change its state. Now, if I have a mass of body this way, Newton's first law of motion tells us that this mass of body will continue in this state except an external force comes to pull it. Now, if an external force pulls this, it's going to cause this body to move. Now, that brings us to the second law of motion. For Newton's second law of motion, if this body is actually going to move, Newton's second law of motion tells us that a momentum will be set up. Now, for this body to move, it will gain a velocity. Let's call the initial velocity u. As it moves, it should have a final velocity at a point in time, and let's call the final velocity v. Now, Newton's second law of motion now tells us that the rate of change of the momentum mu to change to mv is directly proportional to the external force, to this external force that is actually pulling it. So that Newton's second law is saying that F now is directly proportional to mv minus mu over t. So that mv now, if F is directly proportional to mv minus u over t, I can conclude that F now is equals to k into mv minus mu over t. So that F now, collecting like terms, is equals to km into v minus u over t. Now remember from our equations of motion that v minus u over t is the same thing as a, which is our acceleration. F now will be equals to k m a. Now, for F to be equals to kma, in order to define an absolute unit for the force, let's take our F now to actually be equals to 1 and 1 Newton, my m to be equals to 1 kg, and my acceleration a to be equals to 1 meters per second squared. So that 1 now will be equals to k. So that my F, I can conclude, is equals to ma. For this lesson, we are taking our m to be equals to ma. Now let's see. Our example says that a towing van tows a car of mass 1,500 kg along a level road and accelerated at 0.8 meters per second square. What is the tension in the towing van? Now here is towing, this is a vehicle, and the towing van is actually towing this vehicle, is pulling this vehicle. The vehicle has a mass of 1,500 kg and is being towed by a towing van. Let's use this diagram for a towing van. And this towing van is accelerating at 0.8 meters per second squared. Now look at this. F now we have said is equals to ma, so that the force will be equals to 1,500 times 0.8 meters per second squared. That's 1,500 times 0.8 from my calculator. That will be 1,200 newtons. Now, if my force is 1,200 newtons, now the question continues to say that if the towing string suddenly breaks, if this towing string here suddenly breaks, there's a break in this towing string when the car reaches a speed of 20 meters per second. Calculate the distance covered by the car before it comes to rest on application of a brake force. Now, the initial velocity at the point of breaking of the towing string is given to be u to be equals to 20 meters per second, and it is going to come to rest. That means final velocity will be equals to 0 meters per second. Now, let's forget that there's a force of 1,200 newtons being applied. That's another constant. Now, we'll calculate the distance covered by the car. For my equations of motion, remember when we treated the equation of motion, we agree that S is equals to UT plus half AT squared, and also that V squared is equals to U squared plus 2AS. Now we're going to use one of these two formulas to actually calculate our distance. So we must calculate the deceleration of the vehicle to have helped the vehicle move down from 20 meters per second to 0, and also we should be interested in the time taken for this deceleration to have occurred. Now remember that we said that F now is equals to m into v minus u over t. Now if there was a force of 1,200 Newton, that means 1,200 Newton is equals to m. It has a mass of 1,500 and it went down from a velocity of 20 from a velocity of 20 to 0. That means it had 0 here, this is 0, and it went down to, okay, and this is from 20, that's 20 over time t. Now for this, we'll obviously see that my time t multiplying 1,200, that's 1,200 t is equals to 1,500 times minus 20. Obviously my time cannot actually be negative, so that my 1,200 t is equals to 1,500 into 20. Now, and this is negative. Now t now will be equals to 1,500 times 20 over 1,200. 20 here is 1, 20 here is 60. Now this is negative, time cannot be negative, so I'm going to leave out the negative sign. 0 here is 0, 6 here is 1, 6 in 150, that's equals to 25. So t from here is equals to 25 seconds. If t is equals to 25 seconds, I've gotten my t to be 25 seconds. Now you obviously will know that v is equals to u plus at, so that my v, now my v is 0, is equals to u, my u is 20 plus a into t, so that 20 goes to the other side, that becomes minus 20 is equals to a into t. T is obviously t is 20, 25, so that we'll divide both sides by 25, and 25 here is 1, 25 here is 1, 25 here, so is divide 20 by 25, so that this gives me negative acceleration, which is 0.8 meters per second squared. If you divide 20 by 25, you get 0.8 meters per second squared. So we've gotten our t now to be equals to 25 seconds. We've gotten our a to be equals to 0.8 meters per second squared. Then we can obviously calculate the distance using v squared is equals to u squared plus 2as. t is 0 equals to u squared, that's 20 all squared plus 2 into a is minus 0.8 and 10 times s, so that's 20 all squared goes to the other side, becomes 400. That becomes 400, that's minus 400 is equals to minus 2, that's minus 2 times 0.8. Minus 2 times 0.8 s. Negative cancels negative. Divide both sides by 2 times 0.8. Divide this side by 2 times 0.8. Now, so that s now will be equals to 2 here is 1, 2 here is 200. S is equals to 200 over 0.8, which is equals to, so that s now will be equals to 200 over 0.8 is equals to 250 meters. With this, I hope you understand how to use Newton's first law of motion. Thank you for staying with us.